Okay, so today we're going to talk about function operations. Now these functions do both contain fractions. They operate the same way as any other piece of information. If you have two functions, f of x and g of x, you can do many different sets of operations with them. I can add those two functions together. You can subtract those two functions. You can multiply those two functions. Now, with multiplication, whether I say g of x times f of x or f of x times g of x, these two are the same because of the commutative property with multiplication. In addition to that, you can also go through and take f of x divided by g of x. These two are different. They are not commutative. So let's go ahead and do that operation with these. Go ahead and start by adding these two pieces together. So f of x, again, was just 2 plus 2 over x. And the g of x is equal to 1 over x. So I just want to add those together. And f of x just becomes 2 plus 2 over x. And then I add that to 1 over x. Now, because I have fractions, I have to find a common denominator. My common denominator with all of this in this case is just x. So I multiply the 2 by x over x. Now, when you're adding fractions, add everything in the numerator together. So the numerator becomes 2x plus 3, and the denominator is just x. Now, we do have to talk about the domain and range of this. The domain is everything except for x cannot equal 0. So that goes from negative infinity to 0, union with 0 to positive infinity, because 0 is excluded. All right, let's go ahead and do that again, but let's go ahead and subtract them this time. Now, the order of this matters. So if I say g of x minus f of x, or another notation I can go ahead and use is I can say that would be this is g. So for that, still going to use the same pieces. G of x is equal to 1 over x, and f of x is 2 plus 2 over x. So I start with the 1 over x. I subtract everything inside of f of x. Make sure I distribute. So when I distribute this, it becomes 1 over x minus 2 over x. I do need a common denominator, so that gives me an x in the numerator and the denominator, which leaves me with 1 minus 2x minus 2 all over x, or negative 2x minus 1 over x. I don't like that negative in both of them in the numerator, so I'm just going to pull that negative out front and leave that as 2x plus 1 over x. And I could also write that as a negative out front of the entire fraction, 2x plus 1 all over x. Any of those last three answers would be acceptable. Now, before we forget, we have to talk about the domain. F of x, the domain, x could not equal 0. Same thing for g of x. There's no new limitations on our solution, so this has the same domain. The domain is everything except for 0. All right, let's look at two new functions. Our now functions, we're going to have them be g of x is equal to x over x minus 1, and f of x is equal to 1 over x plus 2. Now, before we start with this, we do want to make sure we talk about the domain. The domain of g of x cannot equal 1, and that's because if you put 1 in the denominator, it will give you a 0. And for f of x cannot equal a negative 2. And again, all you have to do is set the denominator equal to 0, and that will be where your limitations are on the domain. Let's go ahead and add these two functions together. What is f of x plus g of x? All right, so f of x is 1 over x plus 2. G of x is x over x minus 1. In order to add these together, I have to have a common denominator. The common denominator that I have for both of them is I need both pieces in the denominator. So what I end up doing is I'm multiplying the top and the bottom by the other piece. So now what I am left with is x minus 1 all over x plus 2 times x minus 1 plus x times x plus 2 all over x minus 1 times x plus 2. So when you're doing these, add your numerator together, which is going to be x minus 1 plus x times x plus 2. That's all over our common denominator, and our common denominator was just x plus 2 times x minus 1. Now I just multiply the numerator out and combine my like terms. That leaves me with x minus 1 plus x squared plus 2x. Yes, you must simplify. So let's go ahead and simplify that out and put it in descending order, and you'll be left with x squared plus 3x minus 1 all over x minus 1 times x plus 2. Now the numerator does not factor, so we have to leave it at that. Let's go back to what we said in the beginning about the domain. The domain in the beginning, we knew that x could not equal negative 2 and x cannot equal negative 1. That still applies here. So our domain for this, starting with negative infinity, goes from negative infinity to negative 2, union with negative 2 to negative 1, union with negative 1 to positive infinity. We're going to do the same thing, but now we're going to do f of x divided by g of x. F of x, still the same function, is going to be 2 plus 2 over x all over 1 over x. Now, this may be the first time some of you have seen the complex fractions. Whenever you have a complex fraction, what I want you to do is think of all of them as 3 individual fractions. So we have fraction 1, fraction 2, and fraction 3. Between those 3 fractions, you have a common denominator. That common denominator between all of them is just x. So what you want to do is multiply everything single fraction through by x over 1. When you do that, what you're really saying is you're multiplying the numerator and the denominator by x. So you're multiplying the fraction by 1. By doing so, that leaves you with 2x, the other x's cancel out, plus 2 all over 1. Or just 2x plus 2. Now, as you're looking at the domain of this, we have to be careful, because if you only look at the final result, you would think that this domain would be all real numbers, but it's not. We have to recall that in the beginning, f of x and g of x both had a domain where x cannot equal 0, and that remains the same for this. So the domain for this, because 0 is not in the original two functions, the domain has to be the same, that this also cannot include 0.